This video is for exponents and scientific notation. So in this lesson, they talk about 4 major rules of exponents. The first rule is if you're multiplying 2 exponential expressions and the base is the same, then all you have to do is add the exponents. The second rule is if you have an exponential expression raised to the 0 power, that's always going to give you a 1. The third rule of exponents in this lesson is if you're dividing exponential expressions and they have a similar base, all you have to do is subtract the exponents. And the fourth rule in this lesson is if you have an exponential expression with a negative exponent, it just changes the position in which that exponent is located. So notice this a to the negative n is in the numerator, but to get rid of the negative exponent, you move the a to the n to the denominator. So let's go through and let's apply these rules to actual problems now. So notice I have the rules of exponents, the 4 that are in this lesson, off to the left here. So for the first example, we want to multiply a squared h by a h to the 6th r. So we can do this in a few ways. I want to start off writing this all out so that way you see the rules of the exponents, and then we'll kind of look it back and apply the rules. So in the first set of parentheses, I know I have 2 a's. So I'm able to rewrite this as a times a. But then I also have an h. So in my first set of parentheses, I have an a times h. But then I'm going to multiply that by, again, in the second set of parentheses, I have 1a. I have 6 h's, so I'm actually going to type out, or in this case, write out the 6 h's. And then I also have an r. Remember, all we're doing is we're multiplying both of these together. So I have a times h times a times h times h times h times h times h times h times r. All we're going to do now is kind of look at how many a's, h's, and r's we have. So if we look at this, I notice I have 3 a's, and a times a becomes a cubed. Now we look at how many h's we have. We have 1, 2, 3, 4, 5, 6, 7 h's, and those 7 h's being multiplied together give me h to the 7th. And then I only have 1 r. So I just leave the r. I mean, you can put the exponent of 1. It's not necessary though. So when I multiply a squared h by a h to the 6th r, I get a to the 3rd h to the 7th r. Again, I kind of showed you that longhand by typing them all out. I want you to actually see the properties now. So in the first set of parentheses, I have an a squared. And in the second set of parentheses, I have an a. Those are both similar bases. Please don't forget that a has an exponent of 1. So does that h. And so does that r. Again, they're typically just not written in. So a squared and a to the first have similar bases, so all I'm going to do is add the exponents. 2 plus 1 becomes 3. So I have a to the 3rd. H to the first and h to the 6th have a similar base of h, so all I'm going to do is add the exponents. 1 plus 6 becomes a 7, h to the 7th. And then r doesn't have any other similar base anywhere, so I just bring it down. So there's a few ways to approach these. I mean, sometimes when you have big exponents like 6, you don't want to write them all out, so that's where these rules of exponents help. Alright, so let's look at a second example. I want to multiply negative 4x squared y by 3x to the 6th by negative 2xy to the 5th. So instead of actually writing these all out like we did in the last example, I want to use these rules of exponents. So first thing I want to look for is I want to identify the stuff I can multiply. So I know I can multiply the numbers because they're just numbers. So I have the -4, the 3, and the -2 that I can multiply. So now we're looking for similar bases that are being able to multiply. So I have a base of x here, I have a base of x here, and I have a base of x here. So I would be able to multiply all three of those. But again, I always like to make sure everything's kind of covered before I do any multiplication. So my other base that I have is y. So there's a y there, and there's a y there. So now we're going to go through and we're going to multiply these. So let's start off multiplying the -4, the 3, and the -2. -4 times 3 is -12. -12 times -2 is 24. So we know that's going to be part of our answer here. So we have 24. Go through now and multiply. Remember, we're multiplying these expressions together. So we're going to combine the x's. And if we're multiplying the x's, all we're going to do is add their exponents. So this x has an exponent of 2. This x has an exponent of 6. And then technically this x has an exponent of 1. It's just not written in. So 2 plus 6 plus 1 is 7. So we have 24x to the 7th. And then we're going to do the same thing for the y's now. So the y's that we underlined here, we're going to combine them by adding their exponents, since we're just multiplying these expressions together. So this y technically has an exponent of 1. This y has an exponent of 5. So 1 plus 5 gives me 6. So in my solution, I'll have y to the 6th. So when I simplify, except I typed the 7 here, and I don't know, maybe did I say 7, but I meant to put 9, because 2 plus 6 plus 1, 2 plus 6 is 8, 8 plus 1 is 9. As I'm looking back at my answer, I caught my error. So I have -4x squared y times 3x to the 6th times -2xy to the 5th becomes 24x to the 9th y to the 6th.